Hey guys, just a really quick review video from the last lesson. Relative humidity tends to be kind of a nebulous, kind of a weird topic for ninth graders. So I just wanted to go over a couple graphs, take a look at some relationships here, and hopefully you can understand a little bit more about relative humidity. So first off, if you look at this graph on the bottom, you'll see that as temperature decreases throughout the nighttime. And this is represented here. You see the dashed line. Temperature here gets colder at night. Noon, it's getting warmer, 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 warmer. Afternoon, the warmest, and then it gets cooler again. So we know this is a normal daily cycle. It's not, what happens every single day. There might be cold fronts or warm fronts, but it's like an average cycle. And you can see that relative humidity is kind of working opposite this. And once again, this is an idealized cycle. It's not normally what happens every single day. But what's going on here is that absolute humidity, which is remaining constant in these top pictures here. That means the humidity in the air, this blue circle, is staying the same size. But while that's happening, in the daytime, the temperature's warming up, and then it's cooling down as the sun comes up, and then the sun goes down. And so what you see in this picture here is that as the air temperature is warming up in the daytime, but we're not adding more water vapor to the air. Remember, this blue circle is staying the same size, all three pictures here. So if you don't allow more water vapor to enter the atmosphere, the humidity is going to decrease. The relative humidity is going to decrease. And you can see that with the 28% right here. The warmer it gets, the lower the relative humidity. If you're not adding more water vapor to the air. But, in the nighttime, the sun goes down, so the temperature is dropping, 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 dropping. And that means that it's like 30 going to 20, 20 going to 10. So eventually it comes to the point where the relative humidity can actually be 100%. The air is saturated, and you might get dew on the grass over the nighttime. And then, it starts to warm up as the sun comes up. And this process repeats. Now, once again, this is an idealized situation. So cold air has much less potential water vapor content because it takes lots of energy to keep water in vapor form. And, this is happening. If you look at graphs of weather forecasts, like if you go to a website called WeatherSpark, and you look at these graphs of relative humidity versus temperature over many days, you can see these things just zigzag. They're kind of like opposites all the time. It's a cool thing. Whoops. Daily cycle of relative humidity and air temperature, and here we go again. Relative humidity, you can see, very high. It's morning time, 6 a.m. And then as the day warms up, relative humidity drops. So as the air temperature gets warmer, afternoon is the warmest time of the day. So when the air temperature is warmer, it can hold more water vapor in it. It can have the potential for more water vapor in it. So the water vapor, the relative humidity is lower. Now, this would change if there was some addition of water vapor into the atmosphere, which we'll learn later on in this unit, coming from air masses that are much more moist. That can change this game. But for now, keep it idealized so you can learn about it. All right, here's a question you might see. The graph below shows the changes in air temperature and dew point temperature over a 24-hour period at a particular location. At what time was the relative humidity lowest? Now remember, relative humidity is the measure of the percentage of water vapor in the air at that temperature. And remember, it's very low when that blue circle and that yellow circle are nowhere near the same size. So when the air can have a lot more water in it, the air is much warmer. And so if you look at this question, the relative humidity would be lowest when that air temperature is really warm and the dew point temperature in this case would be low. But we're looking at the warmer air temperature is the key here. And that happens in the afternoon between 4 and 6 p.m., somewhere in there. And so the best answer here would probably be 4 p.m. So what time would humidity be lowest? 4 p.m. The highest would probably be 6 a.m. And you can see the graphs come very close to touching here, but it's also the lowest point in temperature. and explain one possible reason why the temperature and dew point were almost equal at 6 a.m. And that's simply because the air temperature dropped. That's 6 a.m. is around the time just before the sun comes up, and so the evening has had the most amount of time for that Earth to give off its heat and get cooler and cooler and cooler, and that's why you typically find the frost or the in this case the dew forming just before sunrise. Yeah, and once again, I mentioned this in the last video, explains why those morning gym classes and not the afternoon always gets the wet grass clippings all over their brand new sneakers. In the fall, that's always the case. And then they come to my lab class and leave the grass clippings all over the floor. All right, and we see the same thing here, relative humidity, temperature, they're zigzagging opposite each other. So just remember, whenever the temperature is the highest, in an idealized situation, the relative humidity is going to be the lowest. There's going to be a big swing there. That'd be dry air. And whenever relative humidity is the highest, air temperature would be the lowest. And, you know, you get the idea. And it's usually that case in the morning time. And when the air temperature is highest, it's sometime in the afternoon. And that's it. Just a real quick review of some of these relationships with relative humidity.